Alright, so here I am on page 5. I'll talk about binomial probability distribution. Now this problem is asking about first identifying which of these three situations is binomial. And in this case, we can refer back to the four characteristics of a binomial distribution. Here they are. First, you have to have a finite number of trials, then you have to have independent trials, meaning that the probability of one cannot influence the probability of the next. You got to have two types of outcomes, success or failure. And the probability of a success always has to be the same, no matter what. Now, let's go ahead and go through these one by one, and we'll talk about how these individual situations pass or fail each one of these. So the first one, talking about the finite number of trials. So each one of these cases, it looks like the first one, you've got 10 trials, then 10 trials, then 5 trials. So they actually all fit, they all satisfy this finite number of trials. So that's a good thing, all right? So they all check past the first characteristic. The next one, independent trials. That means after each trial, their results are not going to influence one another. This actually does pass for the coins because the coin's third flip doesn't depend on the first two flips. And the same thing with the 10 people. If you ask 3 people, the third person's response isn't going to depend on the first 2 people's response. Now, the poker hand, it actually does not pass the independent check. You know that it's not independent because the 4th or 5th card you pull depends on the first 2 or 3 cards. Let's say you're trying to pull all aces. Well, if you pull the first 4 cards and they're all aces, then there's no more aces to pull, so you can't do that. Nevertheless, your 5th card depends on your first 4 cards, and so on and so forth. So this option C fails to be binomial, and we know we can just rule that out. The next one that fails is success or failure. The first idea of tossing a coin, you do have a success and failure, but when you're asking people how old they are, that does not tell you if there's a success or failure. If you're categorizing that, you could, but this actually rules out option B. So we've got only option A here for one that is probability, a binomial probability function, and now we got to go on to identify the success or failure. And in this case, my success is going to be, I'll go ahead and identify that. My success is going to be number of tails flipped. The failure is just going to be the opposite of that. Remember, we're defining these in words, so the number of heads flipped. And again, this is something that we're defining in words. Success and failures have to be in words. Now, excuse me, calculate finding P. Little p is equal to the probability of a success. So the probability of getting a tails flipped. Well, the probability of flipping a tails on a fair coin is just 1 out of 2. Likewise, Q, I can now calculate Q. Q is going to be the probability of a failure. So the probability of a failure. And we know that Q is going to be 1 out of 2. You should be able to see that P plus Q equals 1. That should always be the case because if P is not occurring, then Q has to be occurring. So we've got the addition sum property there. Continuing on, the next thing I wanted to identify was N. N is going to stand for the number of trials, and you can see that we're going to be calculating 10 rolls there. The next thing we're going to need to identify is what does X stand for in words. And X is going to really be, it's the number of heads we are looking for. All right. So we've got our situation set up there. Now let's actually go ahead and solve some of these problems. Okay, so here are those problems. We got another situation here. You'll read here that you've got to assume that the coin situation is now not a fair coin, so something changes. Now we have a 75% of chance of getting heads. We already defined earlier that 75% was my success. I'm sorry, well, getting a heads was a success. So now I'm being a new value for P. My P is now going to be 0.75. My N is going to still stay the same. I'm still going to be looking at 10 trials. It's just that P has changed. My value of a success has changed. Now, luckily, I know because I'm using what I did before, this is still a binomial distribution. And that's really, really nice because if I've got a binomial distribution, I can calculate the probabilities very straightforward by using those functions in the calculator or by using the tables in the back of the textbook. We haven't really done the tables as a group, so we're going to utilize the calculator and the function built into the calculator. But before I do that, let's determine what I'm actually calculating on each one of these problems. So the first one, I'm looking for the probability of exactly 10 heads. Exactly 10 heads, that's a really easy thing to notate. I just want the probability of 10 heads. So that's just going to be the probability of 10. What this really is saying, remember, this is the probability of x equals 10. Well, we know that x is the number of heads that I'm looking for, so that's just saying that I want my x to equal 10. I want 10 heads. So that's a really, really good thing because that's exactly what I'm going to end up using. Now, the next one is looking for the probability of at least 4 heads. Now, at least 4, it's a little complicated. The wording changes a little bit, but it is still the same kind of idea. I would be happy with 4, the probability of at least 4. So 4 is at least 4. I'd also be happy with 5 and 6 and so on, all the way up to 10. I'd be happy with all of those. So when you think about the probability of 4, 5, 6, 7, 8, 9, 10, you can view it like that with one probability, or you can think about it as a probability of 4 plus the probability of 5 plus and so on until you add up all of these individual probabilities. And that's perfectly fine solving it that way. That will give you the correct answer. There is a faster way, and I'll show you that in a second. Continuing on at the third one, we'll solve these in a second. I just want to write out what we're solving for in each one of them. Probability of getting at most 9 heads. So in that case, at most 9 heads, I'm okay with 9. I'm also okay with anything less than 9, because if I want at most 9 heads, I'm okay with 9. I'm not okay with 10, but I'm okay with everything below 9. So I can add that up one by one like I did before, or I could use my little shortcut, which I'll use in just a second. Continuing on, probability of getting more than 6 heads. I'm okay with more than 6 heads. I'm not okay with 6 heads, so I want the probability of 7 plus the probability of 8. More than 6, right? Probability of 9, and then probability of 10. Those are all more than 6. Continuing on, the last one I've got here, less than 8. In this case, I'm not okay with 8. I want less than 8. So the probability of 7, then the probability of 6, probability of 5, and so on and so forth, all the way down to the probability of 1. There's actually a mistake right there. Hopefully you saw it as well. This is not the probability of 1. I have to continue on. My very last probability that I'm going to be calculating is the probability of 0. You got to make sure you add that in there. Now, when it comes time to actually calculate these probabilities, again, because we're dealing with a binomial distribution, we can actually use the binomial function we have built into the calculator. So this probability of exactly 10 can be solved by using the binomial PDF function in the calculator. And when you calculate that binomial PDF, it's asking for 3 things. It's asking for the number of trials, in this case it's going to be 10, the probability of 1 success, 0.75, and the number of successes we're looking for, or 10. Again, this is going to be the number of trials, or n. It's going to be p, the probability of success, and then the number of trials we're looking for. When you type this into the calculator correctly, in this case, you should get a value of 0.056. So that's roughly about 5.6%. And you might want to pause and think to yourself, okay, does this make sense? If I've got a coin that 75% of the chance is going to land up heads, and I flip it 10 times in a row, can I get 10 heads? You can about 5.6% of the time. And that is accurate. It's not too bad at all. Now, continuing on with the next type of problems, number 2 is a little bit trickier. So I'm actually going to skip number 2. I'm going to come back to number 2 in a second. I'm going to start with number 3, or I'm going to go to number 3 next. Again, because it's binomial probability, I can use binomial probability functions built into the calculator. And I could, if I wanted to, do this step by step. And I could say, okay, well, I want to know the probability of 9. So what I have to do is I have to find the binomial PDF. So I could do binomial PDF of a project with 10 trials with a success of 0.75, and I want to know the probability of getting 9 of those successes. And then I could add that to the binomial PDF of an experiment with 10 trials, the success probability of 0.75, and I want to know what's the probability of getting 8 successes, and continuing on. I could do that step by step by step. or I could use the other function that our calculator has, and it's called the binomial CDF. Remember, CDF stands for cumulative distribution function. And when I type this in, what this is going to give me is it's still going to ask for those three things. It's going to still ask me for n, p, and x. In this case, my n is 10, my probability of a success is 0.75, and the x, the number of successes that I'm looking for, is at most 9. I want at most 9, so I've got to consider that. I'm going to go ahead and say I want at most 9. The difference with PDF and CDF, C stands for that cumulative, so it's going to take the probability of 9 occurring, and it's going to take the cumulative probability of 9 and everything below that. So it's going to add up everything that I want. And in this case, that's exactly the calculation I want, because I wanted at most 9. And I'm happy with everything down to 0. When I type that in, now before I reveal what I get when I type this in, think about it. Should this be high or should this be low? Should this be a very high value or a very low value? Well, think about it overall. I've got a coin now that it's biased coin, right? It's 75% chance of getting heads. So it's a 75% chance of getting heads, and in this case, I want at most 9 heads. That means I'm okay with 0 heads, I'm okay with 1 head, 2 head, all the way up to 7, 8, 9 heads. I'm okay with all of those outcomes. And all of those outcomes are pretty likely because I have 75% chance of getting 1 heads. When I think about all those cases, it's pretty highly likely. And sure enough, the mathematics aligns with that as well, because the answer to this, when I type this into the calculator, my answer ends up being 0.943. And that's a pretty good little calculation, a 94% chance I'm going to get at most 9 heads. So I'm actually not going to walk through this next one. I'm just going to give you the answer to part 5. So I want you to kind of think through it. You should be able to solve it just like we did before. Thinking about how we did number 3, you should be able to solve the exact same step, the exact same process, and the answer you should get is 0.474. This is the correct answer. If you get 0.756, then you made a mistake. Sorry, those colors are mixed up. You made a mistake if you got 0.756. Go back and think through it again. I'll tell you right now the mistake you made, it's all about your starting point. If you got 0.756, you started 1 too high. I want less than 8. 8 is not less than 8. Okay? So moving on, I'm not going to solve through number 5 like I just said, but I will solve through one of these next ones, either 2 or 4. Let's look at number 4. Yeah, let's look at number 4. Okay, so probably getting more than 6 heads. You've got it right here. You could solve it by looking at the binomial probability of each one of these individually. So you could do, like we said earlier, you could find the binomial PDF of 7. Again, you'll have to take the number of trials you want, the percentage of one success, and the number of successes you want. Add that up all the way down to the probability or the binomial PDF of number of trials you want, the percentage of a success, and the number of successes you want. You could do that step by step. You can get the correct answer, but there is an easier way. And the way to find out this easier way, you've got to understand kind of this cumulative distribution a little bit. To help me with this, I'm going to add a little rectangle. Now I'm going to do a short little shorthand, and I kind of did this earlier and I implied it. But if you see a notation like this, the probability of 1, 2, 3, 4, 5, and 6. What I really mean by that is the probability of 1 plus the probability of 2 all the way up to 6. Now I'm just trying to make this a little bit shorter so that as we kind of read through this, it'll make a little bit more sense. So just know that those two things mean the same thing. Now, hopefully you can see that when you're trying to calculate these probabilities, the probability of 1, 2, 3, 4, 5, 6 plus the probability of 7, 8, 9, and 10, that encompasses the entire sample space, all of the options available. And when you can take in the probability of the entire sample space and you add up those options, you're going to get a total of 1. Now, the handy thing in this situation is what I'm looking for, I'll highlight here in green, what I'm looking for is this probability of 7, 8, 9, and 10. And what's nice about that is if I do some quick 6th grade algebra and I take away this probability from the left-hand side, if I take away this probability of 1, 2, 3, 4, 5, 6. And I'm just realized I made a mistake. I should also have the probability of 0 in there. Sorry about that. Probability of 0. My small little mistake there. But if I take that away from the left-hand side, just doing some simple algebra, it's going to cancel out on the left-hand side. And on the right-hand side, I'm going to have the 1 minus the probability of 1, 2, 0. Oops. 1, 2, 3, 4, 5, and 6. So that's that. On the left-hand side, I'm left with what I had there highlighted in green, which is exactly what I'm looking for, the probability of 7, 8, 9, and 10. The other really, really nice thing about this is that you should be seeing that this long probability over here that I'm going to highlight in yellow, this is something that's really, really nice. This is my cumulative distribution function. So I can use that calculator and get the binomial CDF of a project that I have 10 trials. The solution, the success probability is 0.75, and I'm looking for the cumulative distribution up to 6. So starting at 0, going all the way up to 6, and then I'm just going to carry out the math. I'm going to find out that value, and I'm going to subtract it from 1, and I promise you I'm going to get exactly what I'm looking for. When you type all this into the calculator, you should be getting 1 minus 0.224, and you end up getting a final answer of, I'm going to write it up here because I'm running out of space, you end up getting a final answer of 0.7758. Now, I promise you 100% if you typed in a binomial of each of these individually, you would get the exact same answer. Just add up the binomial for 7, binomial of 8, binomial of 9, binomial of 10, and you're going to get the exact same thing. I promise you. Go ahead and do it. I'll wait. I'm not going to wait, but I promise you're going to get the same thing. I'm also not going to walk through the step-by-step process of doing number 2. I will just put up the answers here inside this little video, and then if you've got any questions on those, please let me know. So like I said, I'd give you the answers. I'll tell you the answer for number 2 is going to be 0.996. It is not, I repeat, it is not the value of 0.003. If you got 003 and you think that that's the correct answer, that is not the right answer, then you've forgotten to do something. I'll say hint, hint, look at the 1 minus that. So hopefully you got the right answers on those. Hopefully you're feeling much better by binomial distribution. Guys, we've done a lot in this course. There's a lot that we've been doing, and I promise you it's going to get easier. It is. Keep it up, keep working hard, and I'll see you guys on Wednesday.